Lesson 06. Graph absolute value functions and transformations. Alright, we could take this all a little bit piecemeal, but hey, let's just do it all at once. Our transformations are, well, first of all, what's a transformation? Changes the graph's size, shape, position, or orientation. And to do these, we are looking at three pieces of the graph. We have our A, our H, and our K. And we'll see those come up several times. The A is the stretch or shrink factor vertically, and this is vertically. So if A is 2, it is stretched out twice as tall. We'll make it look thinner though. If A is a half, it'll be half as tall. Might look a little wider. And you do that by multiplying the y coordinates by A. Why? Because remember, f of whatever is the same thing as y. A reflection will be flipping the graph over a line. Again, this is A. If A is negative, it's flipped over the x-axis. If you're multiplying the y values by a negative, it'll flip it upside down. Translations move the graph. H is how far the graph moves right. And notice it's a minus h up here. So that means if it's x minus 2, we're going 2 to the right. If it's x plus 2, it'll be 2 to the left. And k is how far it goes up. K is at the end. It's a plus k, so if it's plus 2, we go 2 up. In general, you'll do the stretch and shrinks and reflections before the translations because you multiply before you add. Order of operations. All right, the graph of f of x is given, so it's these two black lines on there. Sketch the following functions. Y equals negative 1/2 f of x. So if we compare this to the a, f of x minus h plus k, you can see there's no h and k, so h and k are 0, so there's no translations. But we do have this a. A is negative 1/2. So that means I'm going to multiply the y values. So down here, the y is negative 4. Negative 4 times a negative half is 2. It's up here. Where's another place? Let's go to the other end of the line. Here, that y value is 2. I'm going to multiply it by a negative half. I get negative 1. It's the same x value, just a different y value. So there's that line. And then here's this one. The y value is 1. I'll multiply it by a negative 1/2 to get negative 1/2, which would be about right there. So there we have it. It is flipped upside down because the a is negative. It's reflected over the x-axis, and it is half as tall. Let's try this one. If we compare it to y equals a, f of x minus h plus k, you can see a is right here, and it's multiplied. So a isn't 0, a is actually 1, but multiplying by 1 doesn't do anything, so there is no stretch or reflection. It's positive. But h is 1, which means we're moving 1 to the right, because notice it's minus h, it's minus 1. And k is 3, which means we are moving 3 up. So I'm going to move every point 1 to the right and 3 up. Every point 1 to the right and 3 up. Every point 1 to the right and 3 up. And then you can just connect the dots. There you go. Every point went 1 to the right and 3 up. So let's put this in absolute value functions. Wow. So now instead of f of x minus h, I have the absolute value of x minus h, because the absolute value is our function that we were dealing with. The simplest absolute value graph is y equals the absolute value of x. It looks like a V and actually continues on. The slope, well, the vertex is the points. That point there is the vertex. The slope of the right side is 1. The slope of the left side is -1. So to graph an absolute value graph, you can always do the most basic type of graph by making a table of values. Just make sure you get the negatives also, so you get both sides of the V. Or you can plot the vertex and follow the slope of A on the right. Oh, it's like mx plus what? And negative A on the left. So graph and compare with y equals the absolute value of x. Well, if I go y equals a, absolute value of x minus h plus k, I can look at all these things and let's say a is, it's not 0, it's 1. It's 1 times that. H is 2 and k is 3. So what's this mean? When a is 1, there's no stretch or reflection. However, the 2 means we are moving 2 to the right, and we're going to move 3 up. So that's what we compare it with. If you'd like, our vertex was hk, so our vertex is 2, 3. So 2, 3, that's my vertex. And then the slope is a, which is 1. That's the slope of the right side. The other side will be going down. So I go up 1 over 1. 1 over 1, so I get a slope on this side like that. And then it's opposite on the other side, going down with a -1 slope. Graph and compare with y equals absolute value of x. Y equals 1/4 x. All right, let's compare that with a x minus h plus k. You can see that a is 1/4. So that means it is 8. That's less than 1, right? If it's a fourth as tall, it's actually going to be shrunk. So it's going to shrink by factor of 1/4. It's positive, it's not negative, so it's not reflecting. But the h and the k are both 0, so that means it's not shifting. There's no translation. So comparing it, it's shrinking by a factor of 1/4. Graphing it, the vertex is hk, which would be 0, 0. And then the slope is a, which is 1/4. That's the slope of the right side. So that's up 1 over 4. And the other side will be a -1/4. So it's going down like that. All right, let's graph the absolute value function and compare it with that. So we have everything this time. If we go y equals a x minus h plus k. Well, a appears to be -3. What's that mean? Well, that means it is reflected. The negative means it is reflected over the x-axis. The 3 means it is stretched by factor of 3. H. Now here's the tricky part. It's x minus h. This is x minus a negative 1. So h is negative 1, which means we're going to move 1. It's negative, which means it'll be left. And again, it's because it's minus h. So it's be x minus a minus 1. The minus gave the plus. K is negative 2, which means we are moving 2 down. So that is how it's transformed. But to graph it, it's easiest to go with a vertex, which was hk. In this case, that is negative 1, negative 2. And our slope is a, just negative 3. That's the slope of the right side. So I'm going to, that's negative 3 over 1. So I'll go down 3 over 1. And the other side, go down 3 over 1. And there's your graph. Write an absolute value equation for the given graph. Now we're going backwards. Ooh. So we need to find the a, the h, and the k. Well, let's start with the h and k. That is the vertex right there at the point. The vertex in this one, which is hk, is, what is that? Negative 3, 5. Therefore, h is negative 3 and k is 5. The slope was a, and it's the slope of the right side. So if I just count, it's down 1, 2, 3, 4, 5, and over 1. To go from there to there. Down 5 over 1. That's the rise over the run. Or you could plug in the 2 points. You could call this negative 2, 0. And we could say it's 0 minus 5 over negative 2 minus negative 3. Either way, you end up with negative 5 over 1 or negative 5. So it's y equals a, absolute value of x minus h plus k. A is negative 5. H is negative 3. K is 5. Oh, hey, minus a negative is a plus. So there we are. You could graph it in your graphing calculator and see that it matches.